Okay, this is 14.1. We're doing day 2. So we've already been introduced to sine, cosine, and tangent, and now we're graphing really tough ones. Things that have stretches in the middle, things that have amplitudes that are changed, and negatives in front, and all that stuff. So here's an example one that I asked my students to do in this hour. And for this one, the A would come out to be -2, but that's not the amplitude. The amplitude would equal regular 2. Because the amplitude is just how far is this sine curve swinging up and down. It's this distance. Notice it's not this distance the whole way. It's half that. It's this distance is the amplitude. Okay, so normally on sine it would go up, or cosine, it would go up to 1. But in this case it's going up to 2. So again, if I'm doing cosine, I should do it this way. And cut off this side of it, because that's what sine would have looked like. So here's my cosine to start with. That's cosine. And this one's got an amplitude of 2, so I can make this 2 and -2. Actually, I should move it down a smidge here. There we go. 2 and -2. So far, are we good? Raise your hand if you got the same thing as I did so far. Okay, good. Then the B. The B term is this 4 that can get factored out. Remember me saying if you can factor it, you should. Very good. X. And then 4 times x is 4x. That's good. Minus, I've figured out by now that you just have to divide by whatever you're multiplying by in front. It's just that if it ever is a fraction in front, you better think it through, because it's not dividing by that anymore. Now I'm going to multiply this out. 4 times x is 4x. 4 times 1/2 of pi would be 2 pi. So yay, it's working. Yes, I could reduce this to 1/2 pi. Raise your hand if you factored that part right. Okay. Then your B should have been 4. And what is that? Well, B is, well, I like to do it this way. Period is 2 pi over B. And since my B is 4, I can put a 4 there. And therefore, my period is 2 pi over 4, also known as 1/2 pi. Do you get that this is going to get my sine function done really quick? Normally, it has to go all the way to 2 pi to get finished. This one's going to be finished at 1/2 pi. Therefore, you should have labeled this as 1/2 pi, not 2 pi like it used to be. Raise your hand if you labeled that part right. Okay, good. Then I have a C term. Oh, wait. Then I'm going to solve this thing for B. If period is 2 pi over B, then B is 2 pi over the period. And we already know the B is 4, so it's kind of a, this formula wasn't as useful for this situation, but it is for the problems we do later today. Okay, part C is this part right there. And I would argue that it would be pi over 4, or no, 2 pi over 4, which is pi over 2, not negative pi over 2, but I would accept either one there. And what does C mean? It means, since that's negative, right pi over 2 is where it needs to move. That is called a phase shift. Right pi over 2. And the last thing is the D. There is no thing at the end here, so there's nothing. Can you take care of the door for us, please? There is no move up, so this is none. There's no vertical shift on this problem. Okay. So have I actually taken care of, I would always, when I was done with these problems, check through my little list and go, did I actually do the 2? Yeah, because I made this 2 and -2. Did I actually do the negative yet? No, I didn't. If you forgot that, it's easy to forget. Got to go back and check your equation to make sure you did everything that was changed. That negative, even though it's not part of the amplitude, is part of the problem. And therefore, this thing needs to get shifted upside down. So it goes like this. A blue dotted line is where I flipped it up down, a vertical reflection. All right. Then I can say I've done this part, check. I've done this part, check. Did I do the 4? Yeah, that was by relabeling this. And did I shift it right pi over 2 yet? No. Well, how far is pi over 2? This is how far pi over 2 is. Pi over 2 goes all the way to the end there. Do you get if I shift it that far, it'll actually not change. Is that weird to think? It's like if you have a sine graph, or cosine in this case, it goes on forever, right? If I just take this and clone it, if I shift it to the right exactly far enough, it'll overlap with itself again, and it'll be the exact same thing. Okay, so the way I shifted this, 2 pi, or sorry, the way I shifted this makes it go right on top of itself. So even though I should theoretically shift it over, it's going to look identical to the original. What if I had instead only shifted it like 1/4 of a pi? Do you get then I would have just gone over half this distance? All right. And it actually would have turned into pi, or sorry, sine. All right, so this red line was just there to kind of help me originally make cosine. The final answer is that blue one. Why didn't we shift it again? We did shift it. It's just that it overlapped exactly with the way it was in the first place. Could you have actually moved yours over like this? Sure, that's fine. Nothing wrong with that. It's just a different part of the graph you're showing me. But my original one would have been fine too. Okay, yes? I do ask that you always label 2 spots on the graph. So you kind of got me there. On my graph, I should have this at least one more spot on my x-axis labeled. So that would be pi over 4. If I wanted to go further, I could make this spot be pi over 8. This would be 1/8, 2/8. This would be 3 pi over 8. That would also be okay. But those are kind of nasty ones. I just would ask you to have 2 spots labeled on your x-axis and your right. I didn't. So, yes, sir. So whenever the shift is period, exactly. That's a good summary. So if the shift is equal to the period, then you really are just moving it over exactly this, and it'll be right on top of itself, and it'll be the same. Here's another way to think of that. Remember when we were doing the unit circle? You remember when we were doing like what's sine of, say that's 30? What if I asked you to do 360 from that? Same exact answer, wouldn't it? Because it's the one full cycle around, you get the same exact answers you had before. So if your whole graph's getting shifted 360, everything is going to give you the same answer as before. All right. So you have kind of like learned 2 parent functions, sine and cosine. Would you take 2 seconds to just sketch me sine and sketch me cosine? Just make sure you got the difference between the 2. And then all on one page, let's have sine and cosine, and I'm going to tell you tangent and cotangent today too. If you could make that, not make that noise, that'd be good. Okay, what's the difference? Sine starts at 0. Cosine starts at 1 and goes down in the valley and comes back up again. All right. So these always were 2 pi long. That made halfway mark pi, which would make this quarter mark as pi over 2. 1/2 pi, 2/2 pi. This is 3/2 pi. And this was from 1 to -1, for example. Okay. Well, what about tangent and cotangent? Here's tangent. Tangent has asymptote lines here and here. Wait a minute, the other ones never had asymptote lines. Why? It's because, what is tangent? Sine over cosine. Do you get when you're dividing by something, every now and then you're dividing by 0? And therefore, whenever you would be dividing by 0, it's going to crash. It's going to make an asymptote line. So it's where cosine, here's cosine's graph. Cosine would have been doing this. See how it hit 0? At the moment cosine hits 0, tangent has to become impossible because tangent is sine over cosine. All right, you don't really have to understand that right this second, What you do have to understand is that there's asymptote lines, and the asymptotes happen to be at where cosine is 0. I'll tell you they're at pi over 2 and negative pi over 2. Think about this then. What's the total distance this way that it takes to complete one cycle? Pi. Notice it's not a 2 pi period anymore. Tangent has a period of just pi. Then tangent actually looks like this. And it's got two important spots on it, besides where it hits at 0, 0, of course. And that's at the exact halfway mark here, which is pi over 4 and negative pi over 4. We're doing tangent of pi over 4 when we hit that spot. Tangent of pi over 4 is tangent of 45. Tangent of 45 goes back to one of these triangles. What's the tangent of 45? Tangent. Tangent's opposite over adjacent, therefore 1 over 1, which is 1. So do you get, we have to go up, and wherever it hits up here on this graph, I should have had it be a little sharper turn. Whoa. Back a page. I don't know what just happened there. I'm going to pause for a second. Okay, I got it back. So this, I just wish I would have made it turn a little sharper so that it went through that spot a little better. Okay, and this at negative pi over 4 also hits negative 1. Ugh. All right, so here's a rough sketch of it that I think will get you the main idea. Pi over 2, negative pi over 2. Do you get it only as a period of pi? It's shorter, gets over with quicker. And tangent generally goes like this, and it hits at 1 here, halfway through, and it hits at negative 1 here, halfway through. And there's tangent. So what if I was going to take tangent and do this to it? Well, and this 3 is the amplitude. Wait, what amplitude? Do you get how it's a vertical stretch? So this that used to be 1 high is now going to be 3 high. And this that was down 1 is now going to be down 3. Make sense? Okay. And then this 2 here. Well, that's the B term. I know those formulas for B. And if you solve the thing, it's for period. Period is 2 pi over B. But wait, it's not anymore. And it used to be B was equal to 2 pi over the period. But it's not anymore. For tangent, why would this formula not work? Because it's different. Period's just pi. So this period is now pi. So it's pi over the period and pi over B. So for this problem, as my B term is 2, I could throw in a 2 there. Do you get my period? It's pi over 2. Because there's a 2 here. The period is pi over B, which is pi over 2. All right. That's tangent. So here's a typical question on that. Sketch it for me. Pi over 2, negative pi over 2. How many of you had your asymptotes in there? Okay, good. I can't tell if it's been stretched if you just do that, so I would not give you the credit. But if you label this point that's about halfway over, between 0 and pi over 2, and you put that point in there, and you put a 5 here, and you put the one on the other side in there, and you say negative 5 there, I'll know that you knew we were supposed to stretch this thing and make it 5 times taller. Raise your hand if you had that one right. Okay, good. Now let me change one more thing and see if you know how to react. I'm going to put a 4 in there. Try to figure out what that does to its period, and therefore what you should do to these numbers. There's a formula for that. Period equals 2 pi over b. Wrong. What is the right formula? Pi over b. So use that and figure out how to renumber here. Well, if the period is pi over b and b is 4, then it's obviously period is pi over 4. Notice what did I do to the period? I divided it by 4. That's the same as multiplying it by 1/4. The period, though, is this whole distance. So this is not pi over 4. This was never its period before. But what are we doing to our period? Dividing it by 4. So I could multiply by 1/4 here, and I'd get pi over 8. Because pi over 8 this way, plus another pi over 8 going that way, would give me a total of 2 pi over 8, also known as 1 pi over 4, which is what the period's supposed to be. So these should be pi over 8 and negative pi over 8 is what they changed to. Raise your hand if you had that right. Sweet. You guys catch on fast. That's the cool thing about teaching honors pre-calc. All right, so that's tangent and cotangent. No, wait, I haven't touched cotangent yet, have I? All right, cotangent is the same idea, it's just a little bit different shaped graph. Okay, so I'll make a picture for cotangent now. Cotangent has got the asymptotes in a different spot, because you remember how cotangent is cosine over sine? So that means whenever sine is 0, that's when it has asymptote issues. Here's like sine, right? So whenever sine hits 0, cotangent, which is cosine over sine, would have asymptotes there. If you're not going to remember it that way, totally fine with me. Then you're just going to have to memorize that cotangent is shifted over a bit. And cotangent doesn't rise the whole time, like, you know how tangent was going up like this? It's not like that. It's going down the whole time. Like that. That's the exact halfway mark. And if it's got the same period, which is pi, then this is pi over 2. You might say, but last time, Mr. Server, it was pi over 2 on the outside. That's because this one's been shifted. The total distance here is pi. So it's going from 0 to pi. Half that's pi over 2. Half of the half is pi over 4, and that's where it's 1 and negative 1. So that is a graph of cotangent. All right, to see if you understood that, morph your graph to reflect this. 3 cotangent, 2x. That 3 part's pretty easy, isn't it? By throwing in the 3 there, I just made it go 3 times as tall. So this 1 and negative 1 turned into 3 and negative 3. Okay, how about the 2? I'm going to always refer you to the formulas for that. Period equals 2 pi over b is what you should be thinking in the first place. But this isn't the 2 pi period. This has got a pi period. So it's pi over b. And my b is 2, which means my new period is pi over 2. And that means this whole distance is pi over 2. That means this pi should be pi over 2. And if I make that spot pi over 2, then this has got to be half of that, pi over 4. And this is going to be half of that, pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. And 4 pi over 8 is here, which is the same as 1/2 pi. There. I've changed. I didn't even actually have to change my picture. I just had to change the labels. Raise your hand if you feel like you understand what I just did there. Okay, good. All right. You have learned tangent and cotangent. You now have 2 more functions in your bag of tricks. We also practiced all of yesterday's stuff. Now, what do we have to do? I have to teach you something completely different, but you're going to find we're going to do a lot of referring back to circle trig. The next several months are going to often come back to circle trig. Let me give you an example. Let's say I gave you a triangle and it was in the second quadrant and it had a tangent of 1 over x. First of all, what's wrong with this situation? Tangent's not positive there. Good. How about if I make it like this? Now could we be okay? All right. Tangent's negative in that one. All students take calc. Remember how tangent's positive here and here, but it's negative in here. So then tangent should be opposite over adjacent. So this opposite side will be 1 and this will be negative x. Does that make sense to you? Okay. And this is the angle in question. So what, pray tell, is the cosine of that same angle? But wait, Mr. Server, I need the hypotenuse. No, you can figure out the hypotenuse. I'll pause for a second while you try that. All right, did you figure out that this had to be the square root of, and then you go x squared and 1 squared. In fact, this negative will get canceled off anyway, so it's x squared plus 1. Raise your hand if you had that right. Sweet, then that meant the cosine of that angle must be adjacent, which is negative x, over hypotenuse, square root of x squared plus 1. Who had that one right? Okay. Then, let me give you another one like, actually, you know what? The other one like it, we'll actually do as part of your homework. So everybody find this page with me. It's day 2's homework. Well, this is practice problems. Hold on, I got to get to the actual homework assignment. There we go. This yellow one. It's the first problem from your homework for tonight. Okay. Number 1 says cosine of some angle in quadrant 1. So if you wanted to draw the axis around this, it's like this kind of a deal. Okay, but you don't have to have all that. It says tangent is equal to x. Do you get that that's x over 1? Do you get by saying tangent is x over 1 that they're telling you tangent is opposite over adjacent, and therefore this is x and this is 1? This all making sense to you so far? Okay. And it says verify that cosine of x would be that. Well, cosine would be adjacent over hypotenuse, right? Here's adjacent. So they're saying basically is the hypotenuse for this going to be square root of x squared plus 1? Do you agree? I agree. Good. I'll tell you, B, C, or D, one of them is not right. At least one of them is not right. Okay? You got the same exact triangle set up. So you figure out which of those could not be right. All right, that's the first 4 problems. And really isn't too tough. This one is a short one if you know what you're doing. All right, so let's move on to day 2 stuff. That's graphing tangent and cotangent. You feel like we just did a practice on those? You feel like we've covered that pretty well? Hope so. All right, on to this part. I'm allowing you to skip 28 and 30. Frankly, it would take me a long time to explain how to combine sine and cosine, and it's not something that you have to know how to do. It's kind of a cool connection, but literally I could take a half an hour explaining this to you, and it's not worth it. There's always unlimited cool things I could show you in math, but we have to limit it to how much time we have. This one you should do, And it's not too tough if you know that the initial population is like the starting population. And then if the starting population is at a time, what time would it be in the context of this picture? Well, if it's between 0 and 12, what's the start? 0. So if time is 0, do you get I'm going to stick in a t is 0 right there? And then all of a sudden I just got to find 2 sine of 0. So that means I got to know sine of 0. Well, you could grab a calculator to do it, but do you get that the sine of 0 goes back to circle trig? 0 degrees is where? Right there. What's the sine of that spot? Sine is the y of that spot. You remember where that spot is? What comma what? 1 comma 0. And the sine is the y part of that. Sine y. Remember that? All right. So a lot of review of trig here. So if we're doing sine of 0 degrees, it's 0. And the other way you can do that is, here's the graph of sine. And sine of 0 is right there. What's it equal to? What is the sine of 0? 0. Good. So then that'll help you figure out pretty quickly what the initial population was. And it wasn't 0. Even though we were doing sine of 0, there's still more stuff here. All right. And then it's a wave, right? They're saying that this population does this. Is there actual populations that do that in the real world? Cycle up and down? There is. Like, for instance, grouse in the population. If any of you are hunters, you probably know that there's certain years that are really good for grouse or for pheasants, and other years are bad. They go in a cycle. It'll get higher and higher and higher, and all of a sudden there'll be peak grouse or peak pheasant, and there'll be tons of pheasant running everywhere. You see them running across the roads, and then like 4 or 5 years later, population's down to 0, not 0, but really low. Okay, so it definitely are things that go up and down like this. So this is definitely a doable problem. On to this one. This is the last kind I haven't showed you how to do yet, and I'm about to show you. And this is depths of the water as waves pass the end of a pier. Okay, do you get, if you were standing there and actually measuring, how high is the water now? How high is the water now? How high is the water now? Do you get that it's going to have high and low spots? Because the waves are lapping against the thing, and sometimes it'll be higher and sometimes it'll be lower. And that means if I were to graph it, do you get it's going to generally do something like that if you take the, and that's a sine curve or a cosine. We're using cosine mostly because it just shifts nicer. All right, so I got to show you how to do that kind without actually doing that problem. So imagine for a moment that we had a sine wave, and this sine wave is like the water, so I'll make it blue, lapping, and it's going up and down as it hits this post. Would you agree there's like a normal water line where if it wasn't wavy at all, the water would settle to that normal line? Okay. Then, if I told you that this spot right here was at, oh, let's do this in the context of something that you can relate to. Let's say it's a cosine graph, so I'll make its peak be like right there. And let's say that this low spot was at pi over, no, let's keep our period 2 pi like before. So let's say this spot right here is 2 pi. All right, so let's say this spot right here is at half of that, which is pi, comma 6 foot deep water when it hit right here. And this spot right here was at 2 pi, comma 8. Let's say the water's 8 foot deep when it's on the high part of the wave. Do you get that the dotted line then is exactly between them at 7? All right, then write me an equation for this. Do you get that you know the amplitude? And we'll use cosine. Do you get that you know whether the period has changed or not? Do you know it's been shifted or not based on looking at the graph? And do you know if it's been shifted up or not based on looking at the graph? Yes, you do. You know all of those things. You could, just from this info I gave you, tell me the equation for this. And I'll pause for a second and give you a chance to try it. The amplitude should be the easy part. B If I were you, I'd write out one of those formulas for what the period is. B's got two different formulas you need to have memorized. Okay, here's what you should have been thinking. The amplitude is this distance. It's not 2. I know it's 2 from the bottom of the wave to the top of the wave, but it's half of that. It's only the distance from the middle line up. So that's a 1 amplitude. So it's just a 1 right there. I agree, you don't have to even write a 1 there, because 1 times cosine is just going to be cosine. B is, was this thing stretched or not? Did it finish at 2 pi like it was supposed to? Well, then its B is just 1. Okay, next thing is the C. Was it shifted to the right? Hint, if I shifted cosine over, its peak wouldn't be at 0 anymore. See what I mean? But since its peak is at 0, then either it's been shifted 2 pi, which I would agree you could put a 2 pi in there, or you could say it wasn't shifted at all. The last thing is, was it shifted up? That's the upshift. Yes. The dotted line, normally, the normal line for cosine or sine runs through there. How far up did it shift? Excuse me. So therefore, that's 7. Raise your hand if you had that one right. Good. We're almost done. So now, what you're going to have in your data for the homework there is not this whole picture, but they're just going to give you the low and the high. You have to look through the list and find what was the lowest the water ever was. And let's say that the lowest that the water ever was 6 foot deep. And let's say it was 10 foot at the highest. Those waves are bigger, aren't they? Okay, so what if they say right here was at time, let's say at time 2 seconds, it had a depth of 6. And here, the high spot was at time, let's say, 5 seconds, comma, the depth was 10. I have everything that you need then to write the formula. I have A, B, C, and D. Just from knowing the high spot and the low spot. All right, I'll show you how. First of all, would you agree that this dotted line running down the middle is important? If it's right between 6 and 10, what's it at? 8. And if you're having trouble with that, you just average 6 and 10. You add them together, divide by 2, you get 8. Okay? So then, do you get that that's how much up it's shifted, is 8? All right. Be active. Write this down with me. If you're not writing it down, you're going to remember 10%. That's like 1 letter on the board. Okay? Okay, next part is the A. How much is the amplitude? Don't get trapped into thinking it's 6 and the 10 difference is 4, that the amplitude's 4. It's half of that. And therefore 2. How many would have known to put a 2 there? Okay, good. The next part is the B. That's the period. Okay? The period is 2 pi over B, or you could solve that and say B is 2 pi over the period. Let's do that. B equals 2 pi over the period. What is the period of this thing? Seems kind of like a trick question. But the period is how long does it take to complete a full cycle? Do you get from here to here is half of a cycle? How much time does it take to get from the low part of the wave to the high part of the wave? Well, from 2 seconds to 5 seconds. It takes 3 seconds to get halfway through a period. So how long is the period in this case? It's 6. Because this is 3, and it'll take you another 3 to finish it, makes a total of 6. So its period is 6. I know that feels weird. So if its period is 6, then you'd say it's 2 pi over 6. I just did that wrong. I apologize. Wait. I put it in the wrong spot. Its period is 6. I put it there. There we go. So B is 2 pi over 6. All right, and then the last part is, was it shifted over? Nope, it wasn't shifted over at all because it's still at its peak at 0. And the last thing was the 8. We already had the 8 there. All right, that's just a quick overview. I understand you might still have questions. Unfortunately, time is up in like 30 seconds. So last thing I'm going to say, no, can't answer your question right now, is you need to go to this blue problem and you figure out, I think the low spot and the high spot might be like here and here or something like that. And you figure out then what your period is normally. No, it says here, here's your period. But how long is it between here and here? That you'll have to figure out, and that will, the hard part of this is just going to be figuring out your B. The rest of it is going to be easy. And I would draw it, and I'd figure out the dotted line going through it, and that's the hardest part for today. Okay, that's all I got for you for today.